Let's look at number 4 from worksheet 5. So on this problem, you're given this information. So a ball is thrown with a velocity of 20 meters per second. So this velocity initial is 20 meters per second, and it's thrown at 60 degrees to the horizontal surface. So this is x-axis and this is y-axis, and it says that the ball lands at the same height as it was thrown. Okay, so the ball starts from here and then it lands at the same level somewhere here. So what's the time to the maximum height and what is the maximum height? So when we deal with height, it's vertical motion, so we need to deal with the vertical motion. Okay, so this velocity is a vector, and this velocity could be resolved into x component and y component. Its x component is vi cosine 60 degrees. Again, the way to remember whether it's sine or cosine is if the side is touching this angle or on the side of the angle, then it gets cosine. Okay, and the y component, which is away from the angle, gets sine. So this is vi sine 60 degrees. Okay, so let's talk about vertical motion. So for vertical motion, we always have acceleration equal to negative 9.8 meters per second squared. And we also know that it starts from this level and then ends to the same level. So that means delta y is 0. And oh, by the way, it's asking for the maximum height. So when it's asking for the maximum height, then we don't want to consider that to be 0. Okay, so this is only when we are considering the complete motion, okay, for the total time from this starting point to the end point. But the time for the maximum height from here to the maximum height, or from this level to this level, our delta y would be y max. Okay, because delta y is y final minus y initial. Y final is that which is y max, and y initial is it starts from 0. Okay, so that's delta y. And what else we know? We know initial velocity in y direction, viy, or sometimes you will also see voy, same thing. Okay, here I will just write viy. So viy is vi sine 60 degrees. So in order to find maximum height, we can use this formula. So delta y is equal to v final squared, here it's y, minus v initial y squared over 2 times a. Okay, I don't want to use that equation that involves time because we don't have time. Okay, and this in this equation we also need to know vfy, okay, final velocity at the highest point, and we know that at highest point the ball stops momentarily, so v final y at the highest point is 0. So this thing is 0 squared minus v initial is 20 meters per second sine 60 degrees. Okay, and then we have square over 2 times negative 9.8 meters per second squared. Okay, so you do the calculation, you get maximum height. And once you have that, you can also find the time for the maximum height. So for time, I'm going to use this formula. So delta y is equal to vi yt plus 1/2 at squared. Okay, so delta y is y max. Whatever you get from here, you plug that in here. Okay, that's the value. And then vi is 20 meters per second sine 60 degrees, okay, times t, which is unknown, plus 1/2 a is negative 9.8 meters per second squared, and t squared. Okay, so in this equation you have everything except t. So this is a quadratic equation. Okay, so you will need to solve this quadratic equation to find t. But if you don't want to solve quadratic equation, okay, if you think it's a complicated equation, then you may also be able to do this using another formula. So let me show you the alternative way. We also have v final is equal to v initial plus at. Okay, so here we are talking about the vertical motion, so we need to write y here. So for the maximum height, or the time for the maximum height, this would be 0. Okay, at the maximum height we have 0 velocity, and then viy is 20 meters per second sine 60 degrees, plus a is negative 9.8 meters per second squared, and then t is unknown. So now everything is known except t, so you solve this for t. Okay, that will give you the time for the maximum height. That's part A. Let's look at part B. So part B is asking how long does the ball take to hit the, I think there is some problem with the wording here. So it's asking for the time for the ball to hit the ground. Okay, so the time to cover that range, or starting from here and then back again to the same level. So again, we can use the vertical motion here. Now we have acceleration, we have initial velocity, and for this particular part the total displacement would be 0, because it starts from this level and then end back to the same level. That means delta y is 0. Okay, so we can use this formula. Delta y is equal to vi yt plus 1/2 at squared. Now in this case I'm going to write capital T because we are talking about the total time, okay, not just the time for the maximum height. So the time for the maximum height is denoted by small t, but for the total time I'm going to use capital T. Okay, so this is 0, this is 25 sine 60 degrees, this is 60 degrees, and t plus 1/2 negative 9.8 meters per second squared, capital T squared. Okay, so basically you can take this whole thing to the left, it becomes negative 25 sine 60 degrees times t, and then on this side you have negative 9.8 over 2 is 4.9 t squared. So this t and one of the t square is cancelled, one of the t is cancelled, so then you get t is equal to, also you can cancel negative and negative, so t is equal to 25 sine 60 degrees over 4.9. Okay, and then you can get the time by doing the calculation. So let's look at part C. What is the velocity of the ball when it returns to its original height? Okay, so when the ball returns to its original height, it will have two components. Okay, so it will have this component of the velocity, which is always same. Okay, so there is x component, which is 25 cosine 60 degrees, and for the vertical motion the velocity is always constant. And there is also this horizontal did I say vertical? So this is horizontal velocity. So the horizontal velocity is always same, okay, for horizontal motion. And there is also this vertical velocity, final velocity, and it is not constant because of the acceleration, it changes. So we want to find this one, and then we want to add these two vectors using Pythagoras theorem. Okay, so the combination of these two would be the resultant vector, which is what we want. So first we need to find this one. So we can find that by using this formula: VYF is equal to VI or VIY plus a capital T, because we're talking about the total time from this point to that point. So I'm using capital T here. So VIY is 25 sine 60 degrees, okay, which we already got in the beginning here. So that's what VIY is. And then A is negative 9.8 meters per second squared, and then T is whatever you get from here, that would be the T. Okay, so that will give you V final Y. So do the calculation. You just plug in the number for capital T here, and then get the number for VFY. And once you have that, V final would be, which is this vector, this is V final, would be square root of Vx squared, x component squared, plus Vfy squared, okay, y component squared, just using the Pythagoras theorem. Again, if you have x component, y component and x component, its resultant is given by this Pythagoras theorem. Okay, so you do the math, use this value and this value, and do the math. And we also need to find the angle. So what's the angle of this resultant vector? So that's given by tan inverse of y component, okay, Vfy over x component Vx, and that gives us angle. Okay, so let's see another part. What's the horizontal range, okay, when the ball returns to its original height? So range. Now once we find the time, it's pretty straightforward. So we have time t, and we also know the velocity in this direction. So velocity in x direction is 25 cosine 60 degrees, and then time is, you find the time from the previous parts, and then range is just delta x. So we have this formula for horizontal motion, v is equal to delta x over delta t. So we can write range, which is this one, as v times t, or delta t if you like. So this is Vx, so that's 25 cosine 60 degrees times this is capital T. Okay, so you plug the value of capital T here, and that gives you R. So that's number 4. Now let's look at number 5. So a ball is thrown from the top of a 50-meter cliff with a velocity of 10 meters per second at 30 degrees. So let's say we have 50-meter high cliff, and you throw a ball at 10 meters per second. So that means this is the initial velocity, and it's thrown at 30-degree angle to the horizontal line. So let's see, what is the time to the maximum height and what is the maximum height? So I will trace a parabolic path. That. Okay, so we want to find this maximum height. So the first thing is we need to decide what origin we want to choose. Okay, do we want to choose this bottom as the origin or this top as the origin? And it's all up to you. Okay, you can choose either one as the origin. The choice of origin is always arbitrary. So I'm going to choose this bottom part as the origin. Okay, so this would be my y is equal to 0. So part A, for the maximum height we want to consider the vertical motion. So for vertical motion, A is negative 9.8 meters per second squared, and delta y is y final minus y initial. So y final is starting from here up to here is our maximum height. Okay, so this is final height. Again, we are measuring the height from the bottom, okay, bottom of the cliff. So y max minus initial height. Okay, so initially the ball is here. Okay, so from the bottom of the cliff to here is 50 meters. So that's our delta y. And we also have initial velocity in y direction. So again, you can break this vector into y component, which would be vi sine 30 degrees, okay, the side that is not touching the angle, and then this side is vi cosine 30 degrees. Okay, so the initial velocity would be vi sine 30 degrees, and so we want to use the formula that doesn't involve time, because we don't have time. And we also know at the highest point the final velocity would be 0, because the ball stops momentarily at the maximum height. So we have this formula, v final y is equal to v initial y plus at again, we don't have time, but we can find the time by using this formula. Okay, so this will answer our first part. Actually, to find the time, yes, we need to use the formula that has time, because I thought it's only asking for the maximum height, but for time let's use this one. So this is 0, this is vi sine 30 degrees, plus a is negative 9.8 meters per second squared, and t. Okay, So you can take this to the left, it becomes vi. Vi is 10 meters per second sine 30 degrees is equal to negative 9.8 meters per second squared times t. So you can solve this to find t. Okay, so this is a small t because it's the time for the maximum height, not the complete motion. And then we also need to find the maximum height. So to find the maximum height, we can use this formula. We have two formulas, you can use either one. So delta y is equal to VIY t plus 1/2 AT squared. So delta y is that y max minus 50 is equal to VIY is 10 sine 30 degrees. Okay, and t is whatever t you get from here. Okay, so use that here, t plus 1/2 negative 9.8 meters per second squared and t squared. So y max would be equal to you take this 50 to the right and then plug in the value of t and do the calculation. Okay, that gives you y max. How long does the ball take to hit the come back to its original height? Okay, there is again some problem with the wording here. So it's asking to find the time from this point to the point where it hits the ground. Okay, so to find that, we can use this formula. Delta y is equal to VIY t plus 1/2 AT squared. So delta y, let me read the question again. So it says original height, not all the way to the ground. Okay, so starting from here, how long does it take to reach that height? Okay, so that's very important. You need to read that part. Original height is here. That means for this one, delta y would be 0, because starting from the initial height and then back to the same height, the net displacement would be 0. This is again 10 meter per second sine sine 30 degrees plus 1/2 negative 9.8 meters per second squared t squared. So you solve that for t. Okay, that's the time to reach the original height. What is the velocity of the ball when it returns to its original height? Okay, so to find the velocity, v final y is v initial y times t plus 1/2. Sorry, that's not the formula I want to use. Cross that out. So v final y is v initial yt plus at. Okay, that's the formula I want to use. So this is what we want to find. V final y is equal to VIY is 10 sine 30 degrees, because that's the initial velocity, and then a is negative 9.8 meters per second squared, and then t is whatever t you get from here, you plug that in here. Okay, that'll give us that. And then it's asking for the total velocity, or the velocity vector. Okay, so the ball is falling like that, so it will have this component, vx component, and it will also have this vy component, vy final. So this is the you can write this vy final or v final y. So by that way, sometimes I write v final y or sometimes I write vy final. They are both same. Okay, so this is this velocity, okay, down velocity, because we are talking about the vertical motion. So in order to find this total velocity or velocity vector, we need to combine these two. Okay, so how do we combine that? Just like before, so use Pythagoras theorem. So v final would be square root of x component squared plus y component squared. So x component is same throughout the motion. It's 10 meters per second cosine 30 degrees. It doesn't change. And then you square that plus this is whatever you find from here. Okay, so that's that, and then you square that and then do the calculation. That gives you vf. Now this is a vector quantity, so just finding the magnitude is not enough. You also need to find the angle. So angle would be tan inverse v final y over vx. Okay, so you find that, and then let's look at part D. Let's see what's the part D. What is the horizontal range when the ball returns to its original height? Okay, so we also want to find delta x or r. So starting from here, when it reaches the original height, what would be this range? Okay, delta x. So we know for range we use horizontal motion. So for horizontal motion, the velocity is vx, which is 10 meters per second cosine 30 degrees. And then we also know the time it takes to get from this point to that point, which we already found. Okay, so this is found in part B. So range is vx times t. So plug in vx and plug in t from here and then get r. Okay, so those are number 4 and 5. So please complete that worksheet 5, and then hopefully we'll be meeting in person on Friday.